Good morning, good afternoon, good evening, wherever you may be, and welcome. Today, we at Siemens Polarion are proud to be hosting our third and final live webinar of our series entitled Intelligent Design Control and Mechatronics Medical Devices, using Polarion ALM. Larry is an accomplished technical manager with over 20 years of medical device experience, including high-volume process and product development projects. Larry is currently a Senior Director of Medical and Life Science Industry Strategy at Siemens PLM Software and holds a bachelor's degree in mechanical engineering from Colorado State, as well as an MBA from the University of Denver. This webinar series has spanned 3 months with 3 webinars that have provided an in-depth overview of how to improve your risk management processes. Each webinar has demonstrated how we can help your firm streamline and automate critical traceability needed to build electronic design history files. Webinar number 1 in May focused on incorporating standards and regulation sources into design control. Webinar number 2 in June focused on risk analysis and mitigation, including ISO 14971. The main topic for today's webinar will be to demonstrate how testing features in Polarion answer the multiple demands of design verification and validation protocols throughout your complex design control processes. We'll be describing and demonstrating how Polarion ALM, which is a framework platform, is capable of mirroring virtually any design methodology and workflow or process. In addition to using Polarion ALM, we'll describe our advanced intelligent design control Polarion template, which can help your organization reduce your product development cycles and time to market. And now I'll turn the ball over to Larry.
Thanks, Dennis. Everybody, Dennis, you can hear me okay, right? Just do a sound check.
Yes, I
can. All right,
sound
thanks.
check. Good.
So always like to make sure. Thanks, everybody, for coming today. I'm going to start the discussion, I think, with just an agenda for the day. I'm going to just do a general overview of kind of the 3-part series, what we've gone through, and what we expect to get out of this one. Once that's done, we're going to go through a testing progression. So we're going to start with sourcing, or a labeling requirements SOP in this case. That's going to progress to an IFU requirements document, an IFU test protocol, test runs off of that protocol, and then some automated test results. Once that's all done, we're going to talk about reporting and how do we know we're done, right? So are we done with some piece of it, or are we done with the entire thing? And that really relates to not just test results and kind of how what the status of our verification validation testing is, but also how does that testing progress up into the regulatory submission. So we're going to have a couple different discussions about that. So that hopefully that gives you a sense of what we're going to cover today. In the webinar series, as Dennis said, there's a 3-part series, and what we tried to do in the first webinar is to discuss all the sourcing places that requirements for requirements can come from. And this was, of course, related to modeling, design standards, standard operating procedures, voice of the customers. There's a whole variety of different sources that we get our design inputs from, and we want to make sure that all those are covered in our design control. And in addition to that, some of those sources step on one another, and how is it that we're going to make decisions between these different sources for the purpose of determining what that design input is going to be for this particular design. The second webinar then said, okay, we have this set of design inputs, but those design inputs are also mitigations to hazardous situations. And when we have a hazardous situation, we want to be able to process that hazardous situation in such a way as to determine what the mitigation strategy should be and what the risk is, both pre and post mitigation. So that was the second webinar, as an attempt to show you how these tools can be used to do a very granular processing of risk management. And in this one, of course, what we're trying to say is we've now determined what those inputs are. We've got a design. We've authored a design, both mechanical and software. That's all good and fine, but how do we do our proof? How do we show that the performance of that design is up to snuff and provide the evidence that we need in a regulated way to regulatory bodies? And so that's what we're going to try and hit on today. And so once we've covered all 3 of these subjects, our hope is that we've discussed with you all the different aspects of design control and how to decide that your product, how to build it up into, a data model and how to complete that data model with evidence. So that's really the effort we're going to go into today. So I'm going to go ahead now and jump out into a Polarion demonstration, if that's all right. It's off. And so this discussion, I'm going to start with a discussion about the regulatory submission. So kind of give you an end view. What are we looking for when we're done with this process? And two things really, I think, are in view today. One of them is the evidence that the testing is completed. So we want a test report, and we want that report to display for us the status and the challenges with the testing that we've had. So that's sort of one piece of it. Second piece of it is when we are doing our submission, probably 95% of the submission is related to different types of evidence. And so we have manufacturing, the facility identification. There's a variety of sort of artifacts that go along with the submission that are not related to the design control in particular. But there's a whole bunch of other things, methods for use, declaration of conformities, we have materials for construction, we have shelf life, but also we have a whole variety of different bench test results. And all these things are documented inside the design control. And so what we're going to try to do here is get back to this regulatory submission and give you an idea of how we can pull the different design elements back into the regulatory submission as we go. Okay, so that's the end view. That's where we're headed towards. So I'm going to go ahead and start building out what it is that sort of the content of that evidence. And so in this case, the first step is really the sourcing SOP. So as I said before, we're going to go from a sourcing SOP to, and in this case, we're going to do it on labeling. It really doesn't matter whether we think about this in terms of software testing or in terms of biocompatibility testing. In this case, I've chosen a labeling requirements line only because I had a labeling requirements SOP handy, and I imported that labeling SOP into the system to kind of give you a sense of how this can go. But I would expect that not only can we have different disciplines as categories, but we can also have subsystems or systems as categories as well. It really doesn't make any difference to Polarion how you organize that project and put that project together, and that's sort of the control points. So try and treat this as a generic. We have a labeling requirements line, and we're going to kind of take that from soup to nuts. So in this case, labeling requirements SOP is the document I'm going to talk about, but you can imagine that there's also ISO documents related to iconography for European standards, as an example, for adhesive labels. There's all kinds of different sourcing documents that we have to drive labeling, but in this case, we're going to start with the labeling requirements SOP. And this is a document that I have used in the past to pre-process some of those regulatory documents to try and get into it, everything that's required to do it. All right, so what do we got here? So we got a labeling requirements SOP, and this document has now been imported through our Word importing functionality. And I went through and I went ahead and broke it down by sourcing relationships. And if you've seen the other webinars, you'll know that each one of these solid bars is a work item. And that work item in this case has been identified as a product source. And product sources are defined as sourcing requirements that are directly related to products. And so what we're saying here is this particular requirement is going to impact our product directly. We want to make sure that this one's tied out as part of our design. So I'm going to go ahead and show the work item properties bar on the right. We went through a lot of this functionality in the past, but what we got is a number of different requirements, and these requirements, the metadata associated with those is categorized on the right. And so what we want to do is make sure that each one of these has been accounted for in the requirements document. And so what I've done before the meeting here is I opened up a variety of tabs, and the different tabs have different documents associated with them. So we can see that this one is the IFU requirements document, and it's located in the input space, whereas the labeling SOP is in the SOP space, and it's termed the labeling requirements document. So these are just different documents in the same repository in the same project. Okay, so we have a requirements document, and in that requirements document, we want to go down here and find a requirement that's related to, let's just pick one here, that's a description of package content. So we want to have a requirement in our IFU, and so now we've gone down to a specific level where we're not saying all labeling, right? And as we know in medical device, labeling includes anything that makes a claim about the product. It could be a website, it could be cut sheets, marketing cut sheets, but in this case, we're specifically now talking about the instructions for use. So what do we want our instructions for use to say in particular about this requirement of that we have a description of package content? So I'm just going to go ahead and say that our system will have a contents, what do I say here? A description of package contents. And so now we have a requirement in our IFU that we're going to have this package content description. So I'm going to go ahead and tag that, and I'm going to save it. And what that's going to do is give me, and push it down to Subversion, that's going to give me a unique identifier. And I'm going to say, I want to relate that with a sourcing relationship to this description of packaging contents, right? And so now that this is termed blue, we have that established relationship between the requirement and the package. And I'm going to copy this, and I'm going to put it into our test protocol. So now what we have is, and I'm going to save that because if I don't save it, the linking relationship wouldn't be established permanently. So we have, the system will have a description of package contents as a requirement. And now what we're going to say is, now that this IFU requirements document has been created and we've approved this requirement that it'll have the package contents, we're going to have to do a test on it. So the first step to doing a test is to come to the test protocol. And this is a little bit of a unique technique that I've done, and it's different than I've run into in the past, but essentially what I do is I create a branch document. And in the IFU requirements, what we can do is we can say, I want to do a branch or a reuse of the different requirements that are in this document. And when I create a branch document, what it does is it creates a document with references to all the work items that are in the document that I've branched. And you can see now that each of these requirements are identical to the requirements that are in the IFU requirements document, but they're referenced. You can tell that by the dots on the left side. So we have not a solid bar that says it was authored in this document. What we have are dots, and those dots refer to a referenced work item. Nice thing about that is, from the standpoint of creating a test protocol, is that now I have exactly the same content all the way down to it's the same object, right? We have the same key ID for those work items as is in the requirements document. So I know the content is identical. And so what I do then is I create this test case, and the test case covers the requirements that are above it. And so in this case, we're going to have a variety of different cover page requirements, things that have to be in the cover page. And what I'm going to, so the IFU, or this test case in particular, is going to cover all of the, we'll open the work item properties on the right, and you can see that this test case verifies all the different requirements that are above it. And you can tell that by the verification links on the right side. So in this case, what we're going to say is we just created this new requirement, and I'm going to insert a paragraph below, and I'm going to copy that requirement into this document. You can see now that I've copied it from the requirements document, it's a reference now. It's not a authored requirement. So I've copied that in, and what do we need to do? We need to create a test case to verify that that particular work requirement has been tested. So we're going to say description of package contents. And that's going to be our test case. So we're going to say, okay, we're going to create a functional test case out of that. I'm going to copy this up to the description. And now we have a set of steps that we can create to verify that the system has a description of the package contents. So we're going to say step 1, and we're going to say, what do we want to do here? We want to verify package contents. We'll get to this a little later, but what we can also do in the context of this is we can insert a test parameter. And what that is, that test parameter is the ability to put a variable in our discussion here that allows us at the time of execution of the test run to put a number in. And so sometimes, just give you one example is, and we'll show this later, if we want to put a version. So I want you to pull version X from the shelf, but at the time we're writing the test case, we don't know what that version is. If so, we can insert a test parameter, and that test parameter can then be filled in at the time of execution so that we don't have to have everything predefined as we. So verify the package contents, say are included in the IFU, and package contents are included is the expected result. So what we might want to do, other things, you might want to pull the current version and, and then for device under test, I put these in the wrong order, so whatever. Okay, so we have a description of package contents. Well, it's not enough then that we have authored this set of steps. The set of steps is great, but we don't know now which requirement that it specifically refers to. And of course, in Polarion, we're not concerned about whether it's a one-to-one relationship. In this case, it will be. So we're going to say that this test is a verification, or it verifies that particular requirement. We set that link up, and now we know that those two are associated with one another. But oftentimes, we're going to be using one test case to verify several, as is in this case, several different requirements. Or we might have several test cases that verify one requirement. And as an example, biocompatibility. You might have 5 different tests for biocompatibility that actually verify that the product's biocompatible. So it doesn't really matter whether it's one-to-many, many-to-many. It's really set up to handle all those different types of scenarios. Okay, so let's go ahead and save the document and then sort of review where we're at. I want to make sure from a navigation standpoint, everybody understands what we're up to here. So we have a labeling requirements SOP, which had a requirement on the product. That in turn turned into a requirement, an IFU requirement, which is now being processed in the IFU test protocol. And so the test protocol is a collection of test cases that are specifically tying out all of our labeling requirements that were identified in the IFU requirements. So hopefully that's clear where we're going here. All right, my little thing here is getting in the way. All right, so we have the protocol. So now what we're going to do is we're going to go to our testing area. This is the thing we've been looking for since the beginning. And the way Polarion is really organized from a testing standpoint is we have a set of test cases. And you can imagine that, especially in software related projects, there can be many thousands of these test cases. And they're authored and can be authored inside of documents, and also very commonly, for sake of clarity, commonly, especially in software projects because there's so many of them, we can author those requirements directly in the repository. But for this purpose, I'm going to show you a method for sort of taking it through a document sequence, because the evidence is so much cleaner when we do it that way. We can say we have an IFU requirements or IFU test protocol, and that's been approved before execution of the test cases. And then we have a test results report that can be approved through all the electronic signatures as well. So it's really clean to do in the way that I'm suggesting here, but I'm just want you to understand that it's not necessary that we do it through documents. We can create these test cases and requirements in the repository and treat them on an elemental basis if we choose to. And so this is a very powerful tool to use, especially in software where we're doing lots of different test cases. We might have a bank of 20,000 test cases that we push against a product. So it's definitely possible to do that as well. So these test cases that we've developed then are a great variety of them, but we end up doing is packaging those in the form of a test specification. So generically, the way different industries term this is test specifications, but in med device, I typically call these test protocols. And so we've just talked about how to create a test protocol and to group a set of test cases inside that protocol. So from that point, what we can do, and the way it's set up, is it allows us to do test runs of the test cases. And so we can either do a smoke test, or we can do any combination of those different test cases. We can do a limited set. One example of that is in biocompatibility, if we pass our cytotoxicity test, very commonly you're going to pass all the rest of the genotox and everything else. So it's a good smoke test, kind of a mechanical equivalent to a smoke test in software, where we can do that test, we can document the test results in a limited way, and then put us in a position where we can do the full test and sort of commit to the whole deal. So regardless, these test runs are really a set of test cases that might or might not be associated with the entire test specification. And then, of course, we're going to display those test results after we do the test run, and that'll be the final step in the progression here. So I'm going to go ahead and run you through how to create a test run. And so we're going to go ahead and do that. We're going to call this IFU 005. And maybe we'll put a date in here. Today is 1707. 26, we'll use the European standard. And we're going to create this test run. So what this does is it dumps us into an interface for the test case or the test run that's really blank. We haven't established which test cases are going to be associated with this particular test run. So the next step in the process is for us to go into the interface and create and select the test cases that are going to be associated with this test run. Of course, this page is driven off of, it's a wiki-based page, so we can put any content in this page that you choose to. So currently we're running off of the standard that comes out of the box, but if you want to customize this page, you certainly can. And in addition to that, the searches and a bunch of other stuff are, we're able to save these as templates for time savings later. But just to give you a sense, we're going to go ahead and select the test cases. So this is our repository sorting mechanism, and I think we've talked about this in the past, but it pulls up the repository of all the different work items that are associated with this particular project. And what we're going to want to do is say, well, what specific work items are we interested in? And so I'm going to say, I'm just going to give you a sense of how this sorting mechanism works. We're going to go ahead and say we want functional test cases. And just incidentally, one of the things that we can do is sort them on other things and use our test engine to drive our different types of analysis work as well. So it doesn't have to be just verification and validation. It can also be other types of tests that are sort of smoke tests to find out whether, to do some simulation to find out whether we have the ability to, whether we've specified our requirements properly. But in this case, we're going to say functional test case. We want to look at our functional test cases. Well, so one of the problems here is it pulls up all the functional test cases. And this might, in a project of any kind of size, you might have 5,000, 6,000 different test cases that you're concerned with. And so in this case, what I'm going to say is, I don't want to look at all the different functional test cases. I want to look at the ones that are associated with the document title, IFU, test protocol. And I want to down select them. So now what I have is a set of all the different test cases that were defined in that particular document. And I like this because it makes it really clean. We have as I said before, an IFU test protocol that can then be approved, and we're going to execute our test run against specifically that protocol as defined. So I'm going to go ahead and select all these different test cases that we want to execute, and I'm going to add those then to my test run. I'm going to save the test run. Okay, so now it's waiting, and we'll go back to our testing page here just to take a look and see kind of what we would expect. So again, all these recent test runs that we've defined, we've executed a bunch of them in the past, kind of gives us a sense of test runs and our status, current status of the testing that's happening. And here's our IFU 005-170726. And what we want to do is execute that test run, or that test, execute the test run now. And you can see that we have 6 test cases that are waiting, 0 passed, 0 failed, 0 executed. And so we want to go ahead and execute this test. The way this works then, when we execute the test, is it's going to bring up each one of the test cases in sequence. So the first one's the IFU cover page test case, and this is the interface that we've established with our test steps. So in order to do this, we're going to say start the test case, gives us an idea how long it takes, and I'm just going to go through this pretty quickly. So we're going to say these are included, and we're just going to give them a verdict as we go through. One of these will fail as we go through here, so we don't have nothing but passes. So we're going to say it looks good, and we're going to pass the overall test case. So you can see then what it does is drops us to that next test case, and we have 6 of them in here. So I'm just going to go ahead and we've got to start the test case. So we're going to say included, say it looks good again, and I'm just going to drop through these as we go. Most of these are pretty short, so we'll just do this quick. Start it. Good. This one is a little longer, so you can see in all these cases what we're doing is deciding whether we're going to test one test case as part of this or we're going to do multiples. And so in this case, we're going to say the device model number is not included, for example. So we're going to fail that one, and we're going to say need to include the device model number. We're going to fail the overall, just to give you a sense of how that works. So we'll start the test case, and we'll get the last one. Oh yeah, so this is an interesting, so as I was talking about before, we have this test parameter, and what we've done here is we said pull out, our first step is pull out the current version of the IFU. Well, the current version of the IFU is a variable because we didn't know what it was at the time we authored the test case. And so this is just an example where we can say, we're going to put in the current version of this is 2.0. We're going to save that. And then what we're going to do is update our test case here. We're going to run it again. And so what that allows us to do is, found 2.0 and pulled correct version. So that was okay. And then we're just going to say that's included. And so that's all good. Looks good. So you can kind of get a sense of how to apply test parameters. And this is one of the ways that people do a lot of things, like, as an example, we have 5 fixtures that we could use for this particular type of test, and you can pull any one, but we don't know which one we actually used. Well, we pulled fixture number 3, for example. So there's a lot of good reasons to have test parameters in our test cases. We're going to pass the overall thing, and I'm just going to do this one real quick. So we're done. This is the one we added, I believe. Start it. And good. So that's it. And we have 6 executed. We can kind of see the status of this execution run. We have 6 executed, we have 5 passed, and we have 1 that failed. And so now all of this data has been saved and is part of the test execution driving engine. And the really great thing about this is now this is all data that's in the system that can be processed. And that provides us with a really strong position from the standpoint of not making any errors on the test execution. So again, we have execution and reporting. So we have IFU 005, and 005 is the one we just ran, right? And here is our page that is the test run page. The nice thing about this now is it provides us with all of the information that we want on the actual test run that was done. So we have the test environment. This is all metadata associated with the test run that you can fill in. We have the failed test cases and exactly which step was failed in the test case. So that's all really valuable information. So let's go ahead and go back now to the test report. So in this case, the test report, you can do all kinds of fill-in, right? The background references and sort of information that's associated with the test run. But what we can also do is we can establish in the document properties which one of the test runs are in view for this test report. And so what we'll do is we'll update this now. I'll save it and update it. And what we have now is, you notice that this is a work item, and what it is wiki content. So we've actually programmatically said, for this particular test run, give us all the test results that are associated with that test run. And this is a very nice time saver, because so often the test results are established, and those test results are well understood. What we do when we create a test results document is we're transferring all that data over into a document, and there's just all kinds of opportunities for error. Not only that, but it takes a long time for us to correlate and say, okay, where is my protocol? What should we have done? And give me all the test results that are associated with that, and then type them into a Word document. It's just very difficult to pull all that information together and then correctly put it into the document. And so in this case, what we've done is we've just went out and pulled our test run, which is associated specifically with the test protocol. And we've said, give us all the information, all the test data that's associated with those test runs. And now we have all of the test results automatically populated into the test report. And I believe we can also go to the test results then and say, there's kind of two questions we're trying to answer here. One is, specifically for this particular test report or test run for this protocol, what are the results, which I just showed you in the test report. But in addition to that, we want to say, what are all the test results? So what's the status of our overall project? And so the reporting is a very powerful sort of setup that allows you to show the results for everything. And you can either do current test results, you can do all the test results. Really anything that's included in the data set is something that's available to you for processing. So you can really get down to any kind of view of the data. And the way we kind of term it is, we have this data ball that's been developed with all of the performance and the test data in it. Now it's just a question of what does your stakeholder want to see, and what view of the data is important to you from a closure standpoint. So this really comes back now to that question of done. So we've established what good is. We've now defined how we're going to test good, and now we have all the data related to the evidence that shows that the product conforms with what we've defined as good. That's step one. And now the thing we need to do is to drive that up into our regulatory submission. And in this case, what we have is a tag in each one of these. We got I'll go back to the test protocol. At the beginning of the test protocol, one of the things we've talked about in previous webinars is that we have the ability to track other things besides just artifacts associated with the design. And in this case, what we have is a work item called a standard applied. And what that standard applied work item does is it shows us all of the different standards that we're referencing in the design. So in this case, what we have is a document that says, what are all the documents that we're concerned about here? And what are the current versions of those documents? So 1345, this is actually old, right, 2003, but and it's a great example, actually. When we reference it, then we could say, when we're going to the new version of 1345, where has it been referenced in our design? But we have labeling, we have all kinds of different things, but also what we have are labeling requirements SOPs, we have design control SOPs, a variety of different things. So what that allows us to do then is go back to the report, and I just wanted to show you how we've tagged this report as a standard that is referenced in the design. And we've authored that in this test report. So the significance of that then is when we go back to our technical file has a whole variety of different things we need to reference. Well, what that allows us to do is go to our bench testing results. And our bench testing results are now broken down by the different types of testing that we're going to do. So in this case, what I've done As I say, I have this IFU conformance test, and that's part of my evidence that shows that the IFU was, as a part of the design, has been tested against all the standards. And so what I've done then, you can see that we have references here, right? These are the reference to the particular standards, and those references now, we'll go over here and go to our work item properties. Each one of these is actually exists inside the document that contains the content that we're trying to reference. And so it provides us with the traceability. So now we have an IFU test protocol. Where is this reference contained? The reference is in the standards document, as I just showed you, but it's also in the technical file, which is this document. But where is it contained? It's contained in the IFU test protocol. And so we can hot link right over to the test protocol. And that test protocol is going to be what we just created or added to for doing all of the test cases for the test that we just executed. So if you get where I'm going with that, every one of these bench testing results would have a pair, they have a protocol and a test report, and those are directly linked to the evidence inside the design control. And you can imagine how nice this is for someone in regulatory who's going to be doing the submissions, because as you create this evidence and as those protocols and reports are completed, it provides a place for them to get into their submission, to author their submission with all the data, and as people complete pieces of it, they can review that and come back to this data and see not only are we doing the right tests, are we doing the test in the right way. And one example that I have is I did a biocompatibility test and I got a deficiency noted by the FDA. It's always down in the meat, it seems like. So it's not did we do, the test or not. It's we did the test, and when we prepared the sample, there's a rule around preparing the sample, and was it the right rule that we referred to? And you get a finding that says we're missing some piece, or we did the sample prep wrong, or in one case I ran into it was a polar versus non-polar. So, the device was in urine, and so we had to do leaching materials off of those devices, both with polar and non-polar substances to get all this stuff off of the plastics. So it's always way down in the meat. And so those protocols, as you develop them, will have all the sample prep in them, and they'll have all the different information that's required to actually execute the test. And I think one of the real powers of a system like this is it has the ability to boil the ocean. Right? One of the things people tell us not to do is get too involved in all the detail. But frankly, this medical device business that we're in is nothing but detail, and we need systems that allow us to drive very fine detail all the way down to the evidence and back into the submission in such a way that we can rapidly get at that data. And so when we start talking about time to submissions or time to approval, how long does it take us to get our approval from the regulatory bodies? This kind of detail is just absolutely critical, both to assuring that we get it right the first time, but also rapid response to any deficiency that might be noted by the FDA, so we can get this issue resolved as soon as we can if there is one identified. Okay, so we're sitting at about 45 minutes, and I think that probably gets us pretty well through all a good portion anyway of the functionality related to testing and how that relates to the overall design control and getting our submissions done. And so I guess at this point, what I'll do is open it to any questions you might have.
Thank you very much for your presentation and the detailed demo, Larry. We now have a couple of minutes left to have a look at the audience's questions. So Larry, if you don't mind, I suggest that I read the questions for you and we walk through until we are running out of time.
That sounds great.
Okay, so one of our attendees asked, how is reuse of requirements addressed with Polarion?
Yeah, okay, so there's So there's a progression, I think is probably the best way to put it. There's reuse, which is where we take our work items and we create new work items of a new number, but with identical content. So what we can do is we can say we have a document and we want to create another document that's just like this one, but as a starting point, but we're going to have new work items and we're going to have a new numbering system, and we just want to make all that content copy over. So that's sort of the simplest version of reuse. Second set is a branching. And what that allows us to do is create a new document with identical content. And what I mean by that is everything down to it's the same actual work item. So it's in this case, my example was to create this IFU test protocol. Let me just jump over to that so you can see it. And each one of those work items in the test protocol are referenced. And you can tell that by the dots on the left side. So what I did on this is I created a branch document that contains the identical work items in it that are actually contained in a different part of the document. And then if we want, and this is actually a requirements document, I can add specific requirements that are specific to this particular thing I'm working on. So let's say I have version 2 that's coming out, and we're going to have all the same requirements we had before. We don't want to repeat all the testing for those. We just want to create a couple new features. That would be a case where branching really makes sense. The last one, and so this is, we really cover the entire gamut of reuse. The last one is variant management. And so one of the most powerful ways to manage requirements is to do it in the terms of what they call a 150% requirements document. And what that is you have one document with all the requirements for all the different variants. So 150% of the requirements that are required to build any particular variant of the product. So everything's in that. And then what we do is we use a rules engine to map to the features. So which requirements are required for each feature of all the different variants that are available to us. And then finally what we do is a pick table, and that pick table allows us to assign features to particular variants. And so this is a very powerful capability that allows us to generate those variant product requirements documents automatically on the basis of rules engine and a pick table. So kind of we have the entire gamut, everything from something super simple to the very capable and more difficult case of driving many product variants from a set of requirements. So kind of the whole gamut. Hopefully that gets the question answered.
Thank you, Larry. Okay, so we proceed with the next question. One of our attendees asked, are these references placed automatically into the test protocol?
Say that again, are the requirements automatically placed into the test protocol?
The references.
So they are placed automatically into the test protocol if you create a branch of the requirements document. So when you create a branch document, what that does is it automatically places those reference work items into the new document. You don't have to do it that way, but it's absolutely possible. In addition to that, you can the documents are open at that point, so you have all the references in, and you can add things if you choose to, or you could add references from different documents if you chose to as well.
Okay, thanks, Larry. And here's the next question. How can simulation be integrated into the data model?
A couple different ways. And one of the ways we can do that, and it occurs to me that oftentimes design inputs, as we talked about in the past, sourcing documents determine what should the design input be. And so one of the ways we could do that is create a work item that is a simulation work item of a variety of kinds. And I actually have a couple examples here. I have FEA and computational fluid dynamics in this particular project. But what that allows us to do is to say the place that we got this design input from is from a simulation program. So we did a simulation on the heating in a cabinet. And we wanted to assure that our requirement that it not go over 100 degrees is correct, as an example. So we could link that as a sourcing requirement, and then anytime we looked at the design input, we'd have this relationship that allowed us to understand where that requirement came from. So that's one way to do it. But I think maybe a better way to do it in the context of the tool, and I've been sort of playing around with this lately, is to make it a test and drive it through the testing engine. So if you want to, what you can do then is create a work item type, and this is all pretty rough because I'm getting a sense of how I'd like to do this, but we created this work item that has computational fluid dynamics and finite element analysis. And what we did is created a linking relationship between those two things and the design input. What that allows us to do then is marry the design input both to the verification test case and to these analysis test cases. And then we can do a test report that shows what the content is. So let's just go to our, I think I got a report here, design simulation, yeah. And so what we're doing here is we're saying, show me every requirement in a flat format. So you can imagine in these design projects, we have a V model, we have system of systems, we have multi-domain systems, we have single domain systems, and we have all the design requirements. So going down our V model, we have a whole sort of progression of nested requirements to decompose from one level to another. So in this case, to make it simple to view, because if we do it that way, we have a 20-column table. To make it simple to view, I put all the requirements in the left-hand column flat. And then we are showing on the right side here all the different test cases that verify those requirements. Well, what I'd also like to do is show the simulation testing. And the neat thing about that is we can have a different relationship between the functional test cases and the requirements than we do the FEA as an example. And so this is a verification test, but this is not. And what that allows us to do then is drive our simulation testing through the test management system and task our FEA people with all the tests that they need to do for this particular project. And that occurs to me to be a very strong way to do it, because when we are pulling up our design validation or verification, I want to do verification, design verification testing, the right side, what it gives us is all the defects, right? So if we have a defect, if I didn't show this, but if I show the test results, what we get if we fail one of these tests is an automatic creation of a defect. And just incidentally, those defects, when we can create a task and then we resolve the defects through the task management system. And the really great thing about that is we can also, in Polarion, in the case of software, we can attach those defects to commits in Subversion or in Git or any of these other databases. Or we can actually now, with the latest version of Polarion, we can reference a particular line inside of the code. So when we fix a defect, we can reference specifically how that defect was fixed. And that's a pretty awesome way for us to keep track of all the changes that are made in software and right down to the line of code. But in any case, what we have then is the simulation test. Go back to that. The simulation allows us to drive that testing, and you can imagine now if we failed this simulation test, it would show up as a defect, and that would come back to the design staff for resolution, and then we could roll it through the testing engine. So it seems to me that testing is a very powerful way to drive our simulation. Hopefully that gets an answer out there.
Thank you, Larry. Okay, so we planned 10 minutes for the Q&A. So we appear to be out of time, and we need to end our webinar now. Special thanks for our speaker for today's presentation and for answering these interesting questions. And Dennis, thank you for your introduction. And of course, thanks to all of you for joining us to learn more about Siemens PLM software and medical device intelligent design control. Again, thank you for joining, and Have a great day.